Everyone, and welcome to this second video on sketching polar curves. In this video, we're going to have a look at curves called limacons. This C here with a tail is called a cedilla, and it turns it into an S sound, which is why I call it a limacon. So just something interesting, limacon in French, in Old French, literally means snail. So it's probably some reference to the shape of the graphs and curves that we end up getting. Okay, so we are going to have a look at two types in this case, in this video. The first is in the form R equals A plus B cos theta, and in your exams, your books, etc., you might often see it as this, or R equals A times 2 plus cos theta, etc. So we're going to look at cos theta, and we're going to have a look at sine theta. Right, so there we go. The shape of this curve, in all cases, relies on the relationship between A and B, and I have summarized this here for you, the four different types of curves that we get. In the first instance, we have that R is equal to A plus B cos theta, and the value of A is less than the value of B. And in this case, we get a graph with an inner loop, as I pointed out below the axes, an inner loop. I'm just going to label my axes 0, pi by 2, 3 pi by 2, pi, pi, 3 pi by 2, and then I get back to 2 pi. When we have an inner loop, I'm going to, let me just sketch the graph of cosine. So there are my key points, 1 and minus 1. And remember, you can always just plot some values, a table of values, if you forget what these look like. So if I have cos of 0, I get a value of 1 over here. Cos of 0 gives me a value of 1, which means I'm going to get that R is equal to A plus B. R is equal to A plus B. So that means when theta is equal to 0, I'm starting here at A plus B. And then essentially, as I'm moving towards pi by 2, at pi by 2, I know that cos of pi by 2 is 0. So therefore, R is just equal to A. So I end up here at A. So my graph starts out like this. And it's going to continue, come back on itself, and go through 0, 0. And it's going to form this inner loop. And then it's going to go through A again at 3 pi by 2. And then it's going to go back at 2 pi to A plus B. And that is what the graph looks like when A is less than B. We refer to it as having an inner loop. In the second scenario, I have that A is equal to B. And these graphs end up becoming a cardioid. We call them a cardioid, and they are sort of heart-shaped. Again, when cos is 0, I have a value of 1, so I'm going to start here at A plus B. And I'm going to continue. I'll end up crossing at A. And what happens then is I stop here at 0, 0, and this heart shape continues symmetrically below the initial line. So I have A plus B, this is A, that's obviously 0, and this is A as well. I should add that on this diagram. And just quickly going back to this diagram here, that value there is A as well. And you can obviously work that out by looking at the graph where this becomes 0 again, and that's why I'll end up having r equals a. So there we go. That is the first two, a cardioid and an inner loop. This one does pop up a lot in FP2. This one does not come up. Generally, you will be given the graph and have to solve problems from it. But it's good to know what it looks like. When A is greater than B, I have what is called a dimpled limacon. And again, I start at A plus B, and same thing happens. I go along to A, and then I have this dimple here. So I'm not going to 0, 0. That's what happens, and I go back to A plus B. Still intersecting at A when I get to pi by 2 and 3 pi by 2. And this value here is actually the modulus of A minus the modulus of B. So mod A minus mod B. Or just A minus B in this case, because both of these we are assuming to be positive. Okay, that is a dimpled limacon. I get a dimple effect going on here at pi. And then when A is a lot bigger, right? Oh, I should put a lot bigger. So I write that as, strictly it's when A is greater than 2B. This is when A is a little bigger. I'm going to get that. When A is a lot bigger, this dimple here actually straightens out. So I end up getting, again, start at A plus B, goes up to A, and I actually get this convex shape occurring. Convex shape that occurs. That's still mod A minus mod B. That is A, and that's A. So a convex shape, or a convex limacon. There you go. Those are the first four. The other thing I wanted to point out is, remember we said if anything relating to cos has symmetry about the initial line, and anything relating to sine will have symmetry about pi by 2. So perhaps that already gives you an idea how these graphs will look. They'll keep the same shapes, they'll just be in a different position. Okay, what about when B is negative? When B is negative. And essentially, these graphs are going to be identical, the same shape. Let me put it that way. Same shape, but mirrored in the x-axis. Mirrored in the x-axis, which means I'm going to end up getting, starting there, and get my inner loop this way around. This is going to start there. This will look like this, have a slight dimple, and this shape is going to be convex. So not that great a drawing for these, but you get the idea. Same shape, but as above, but mirrored in the x-axis. Okay, let's have a look at r equals a plus b sine theta. Remember we said here then we will have symmetry about the x-axis. For the rest, the shapes will stay the same. And I'm just going to draw out sine graph. It's always useful to refer back to this to make connections. So max at 1, pi by 2, pi, 3 pi by 2, down to minus 1, and so on. Okay, so when theta is equal to 0, I end up having r equals a plus b sine 0, which means I'm actually going to start here. And I will have, hang on, that's not a great drawing. I will have this happening. I'm going to try that again. I'm going to draw this out neatly. It's going to, there we go, third time, much better. That's A plus B, and that's A as well. Right, when A is equal to B, again I have a cardioid, but this time it's centered or symmetrical about the pi by 2 axes. So when I sketch this out, it's going to look like this. And I know that strictly speaking, I should start measuring, I should start plotting from there. A plus B, A and A. There is my cardioid. When A is just a little bit greater than B, I have my dimpled, slight dimple there, dimpled Limason. That's A and A plus B and the modulus of A minus B. And then when A is a lot bigger, strictly speaking, when A is greater than 2B, I will have my convex, and which means the dimple straightens out, and I end up getting something that looks like this. Mod A minus mod B. Okay, and then if I had A minus B sine theta, the same shapes, but in this case, it is going to be reflected in the x-axis. Do you know what? I've just realized I said x-axis here. I obviously meant in the y-axis. Mirrored in the y-axis. In this case, it's going to be mirrored in x-axis. So I will have my inner loop, which is easier just to sketch this way around. Looks like that. I will have my cardioid, which looks like that. I will have, when A is just a little bit bigger, I'm going to have my dimpled Limason, which looks a little like that. And when A is a lot greater, strictly speaking, A greater than at least 2B, then the dimple is going to smooth out, and I'm going to have a convex Limason. And in each case, you know that the points of intersection will stay the same as above. Okay, I hope that was useful. We're going to go over this in lesson again in more detail. I just wanted you to get an idea and a flavor for what these graphs look like, so that when you see the equations, you start recognizing how they would look if you are not given a diagram. But as I said earlier, generally you are given a diagram in the FP2 exam, and you will be working from that diagram to solve your problems. As always, if you have any questions, please do let me know.